Hey everyone, my name is Yohan and I work as a Senior Cloud Developer Advocate in the JavaScript team here at Microsoft. In this session, we'll explore how you can develop generative AI apps using LangChain.js and Azure. We're still at the beginning of exploring what you can do with generative AI, and the field is moving fast, very fast. Like, you get new models, new libraries, new frameworks every week. And when things move fast like this, you need to be able to experiment and iterate quickly. First, to validate your ideas with a prototype, and then to scale up to production if it works. So, let me introduce you to LangChain.js, a JavaScript library for working with large language models. And if the name sounds familiar to you, it's because it's the sister project of LangChain, which was initially made for Python, and it's a hugely popular open source project in the AI community. So, what LangChain provides you is high-level abstraction for models, vector databases, agents, utilities, and all the plumbing stuff that you need to connect everything together when you're working on a generative AI apps. What's also interesting with LangChain is that this abstraction allows you to easily move between like a local prototype that's using local models, local databases, to a cloud-based model just by swapping the components very quickly. And it's also part of the name as LangChain. The chain part means that very easily it allows you to create complex composition between models and data for like more complicated use case. And we'll see that in the demo just a bit later. Let's start with a simple idea. So I'm from a generation who grew up reading books and articles, but nowadays, let's face it, most of the interesting content is in video format. So I thought that it would be nice to have a system where you can ask questions about a YouTube video and get answers quickly in a text format without having to watch the whole video. Like, you know, some of the videos are very long, maybe 1 hour or more. And if you have like a very simple question, you don't want to have to scrub through like all that videos just to find your answer within that. So yeah, just experiment with that idea. So to implement this, we'll use this approach that's called Retrieval-Augmented Generation, or RAG for short. RAG is a combination of two components, a retriever and a generator. And it works like this. You have your user, and it's asking a question. The first thing is to pass the question to the retriever component. So what this component will do is perform a search within a knowledge base of text documents and retrieve what are the most relevant documents to answer that particular question. Once you find the relevant documentation for the question, you send the documents and the initial questions to the generator component, so the LLM in our use case, and just to generate the answer, the final answer to the user. In addition, it's also useful to use RAG because like video content is often very long, it contains a lot of information, and we want to be able to retrieve like the most relevant piece of information and then generate a precise answer to a specific question. And one of the benefits of using RAG, it's also that it grounds the answer in a set of documents. This is to avoid the generation of irrelevant or completely even made-up content. So, to implement this, first you need to build your knowledge base. To do that, you start from the pieces of text that will constitute your knowledge. You pass a piece of text through what we call an embedding model. It's a specific model that will transform the text into a vector representation. So this vector is called an embedding. An embedding, it's basically a vector representation of a piece of data that captures the underlying structure and the relationship between the different pieces of data. Said otherwise, it captures what's meaningful about that particular content in the piece of text that you provided. Once you have your vector, you also get the initial text and you mix them together to create a document. And this is what you will put in a dedicated database that we call a vector database. The next step is to implement the retrieval and context augmentation step. So we start again from the user create the initial question. We send that question through the same embedding model that we used before to have a vector representation of the question. But this time we'll use this vector to perform a similarity search inside our vector database that contains our knowledge. So from that search, we'll pick up the most interesting, the most relevant results. We get the text from the documents from these results, and we will use the text from this document to augment our prompt. And our final prompt will go with something like that. Hey, answer the following user question, then you insert the question, using the following set of documents, and then you insert the documentation. So nothing too fancy in there. Now let's see how do you implement that in practice using LangChain.js. So first, we'll start with a local prototype because it's easier and cheaper also to experiment when you're working with everything locally. To do that, we'll use a tool that's called Ollama. So Ollama is a command line tool that allows you to download and run open source models locally on your machine. So for example, let's see all the models I have on my machine in there. So you can see I have a few different ones. The one we will be using for generating our embeddings is this one. It's a very small model. As you can see, it's only a few megabytes. And we will use this one to generate the vector representation from our pieces of text. And we will use the Llama 2 model for the generation part as our LLM. The Ollama tool allows you to run the model locally. Let's say, for example, I run the command Ollama run Llama 2. So it will initialize the model. And then it will basically behave like a minimal sort of ChatGPT right in your command line. For example, I can ask a question, who is Satya Nadella? I get the answer, okay, it's the current CEO of Microsoft, and I get all sorts of details. What you cannot see from that is that when you're running a model, it also exposes you with a web API that you can use to build your application locally. And that's what we will use with LangChain now. So let's move on to the code. So first, let's just say we're focusing on the most important thing right now. So we are working on a prototype. Of course, I won't build a fancy UI just where you can impute like your question and your YouTube video reel. So let's assume we will keep that part for later. So for now, I will be using these two constants to get the YouTube video that we want to question about and our question. So just to give you some context, this one I use there is the last Microsoft Ignite keynote where a lot of announcements were made about the latest advancements about Microsoft products and AI. So this video is quite long, it's more than an hour long. So let's say I have a simple question like what are the news about GPT-4 models? Let's see if I can get an answer through LangChain.js to generate without having to like scrub through all that long video. First thing, we need to build up our knowledge base. So we have this YouTube loader component that's built into LangChain. So as I said before, there are a lot of utilities in LangChain. So this one allows you just starting from a video URL. You specify the language, and you can load the transcript of that video, just like with these 2 lines of code. So once I get the full transcript of that video, we'll process it a bit further because, like as I said, the video can be quite long. In that case, it's more than an hour of text, so that's a huge amount of text. And what we want to do is first to chunk this huge text into smaller pieces. And we have another LangChain utility, that's the recursive character text filter, that will allow us to do that. So we specify a maximum chunk size, in this case 2000 characters, and some overlap. just to make sure we keep a moving window, so we keep some of the context before and after the chunking part. Yeah, this utility will try to be smart to avoid splitting in the middle of a phrase, if it's possible, or of paragraph. And at the end, what we'll get is the set of documents that we want to convert to vectors to create our knowledge base. So the next thing we want to do is to initialize the models and the database. As I said just before, we'll be using Ollama. And LangChain.js provides connector for Ollama, of course. So here we initialize the model for embeddings with Ollama embeddings. It will take care of running the model in the background. I just specify which model I want to use, so this one for embeddings. And then the one we want to use as our chat model. So chat Ollama, and I said I want to use Llama 2. Next is our vector database, and we want to use one that's able to work locally, so I'll be using Face. I'm not sure that's the right way to pronounce that, but it's a file-based local vector store that we can use to perform similarity search. Next, to convert our documents into vector and put them in our database, we just need to call the addDocuments method. And it will take care automatically of the conversion from these pieces of text, running it through our embedding model to convert them to vectors and ingest the result into the vector database. So just running this single abstraction function addDocuments will do all the steps that you need to do just that. And now let's move to the core of our method. So we will implement the RAG pattern in there. The first thing is to craft the prompt. So we're using a chat model. So that means we have the possibility to inject a system message, a human message, and AI messages. The system message is the one with the highest priority. So that's usually the one you use to specify what you want to do, like give the ground rules for the generation that you want. So in our case, it's pretty simple. I use a naive prompt in there, answer the user's question using only the sources below. And it's a template. That means that with LangChain, using this bracket thing, you can specify a placeholder for variables, and this will be replaced at a later part in the chain with the proper text documents that will come from our retriever component. And we'll do the same for the human message that will contain the initial question. So this is the input placeholder, and we'll replace that by the user question. Next, we use our first big components in our chain. It's also built into LangChain, is the create stuff document chain. This is the one, not really an explicit name. This is the one that will get a list of documents and convert that to text to replace that placeholder in there. So we give it the prompt, the one we just made before. We specify which model we want to send the completed prompt to get the final generation. And we move on to the next part of our chain. And the next part is to create the retriever component. So we have also this built-in component that's called the retrieval chain component. We specify which retriever we want to use. So for this use case, we will use the vector database that we created just earlier, and we can convert that as a retriever. So it will take care of taking the input, converting it to an embedding, perform the vector similarity search, get the result, pass the result then to our stuff document chain, and these results will be converted into text, injected into the prompt, and then we can get the final answer. Once we built this complete chain, we just need to call the stream method if you want the result to come as the generation is done. And we specify here what's the value for our input variable, and we pass our initial question. Then we get the stream response, and we can do whatever we want. If it's an API, you can return the stream result, or in our case, we will do something more simple. We will just print that into the console. Okay, so let's see what's the result of that, and let's check if it works. So I will run my program using Node.js, so everything is made in JavaScript, as you've seen. So the first part, you can see it's very fast because everything's working locally. It will load the document from YouTube, convert them to embeddings, and then we can see the response to this question: what are the news about GPT-4 models? And yeah, everything comes here from the local models that I run on my machine. So I can see the response in there. Okay, there are several exciting updates about GPT-4 models, like lower pricing with GPT-4 Turbo, new structure and JSON formatting, okay, extended prompt length, and yeah, new things about latest GPU accelerator. So yeah, let's try to run it again, because it's generative AI, the answer can be a bit different. So let's just run it a new time just to check that the answer is almost consistent. Okay, so it's formulated a bit differently, but yeah, the meaning is basically the same. We got news for GPT-4 Turbo lower pricing, the structure, JSON formatting, new prompts, and a new innovation regarding like the silicon part. So yeah, now we have like basically validated that our idea works with a prototype. So the next step is how we can take that prototype and transition the code to using models that are suitable for production. And I want to use, instead of using everything locally, I want to use Azure component to do that. So I won't show you the part where I go into Azure to create like the different resources. I will show you how this impacts the code. So let's go back to our prototype code. I will need to change a few imports in there. And yeah, for the models, I will use Azure OpenAI. I want to use GPT-4 Turbo for our chat model, and I want to use like the new text embeddings large free model also to generate the embeddings. And for our vector database, I want to use Azure AI Search. So I've just changed the import in there. The documents loading part doesn't change. Basically, I'm still using the YouTube loader. I get the text from that, and I chunk it to get all the documents. What I need to change is how we initialize the model. So we won't be using Ollama embeddings in there. I want to use Azure OpenAI embeddings. And for the chat model, it's the same. I want to use Azure Chat OpenAI. So I don't specify anything about which kind of model I want to use and how to connect to Azure OpenAI, because as I said, I want to migrate to use production application. So that means that everything will be passed as environment variable. I can show you this .env file that I'm using in there to test that locally. So of course, I won't show you the secrets, but you can see like the connectors to connect to Azure AI Search, Azure OpenAI, and you can see also the models names that I will be using in there, like GPT-4 Turbo, as I said, for the chat models, and text embedding free large for the embedding model. So next, we want to replace our vector database with Azure AI Search. So what's interesting with AI Search is that you can use, of course, the regular vector search thing, but you can also combine regular vector search with semantic search to improve the results. That's what we call hybrid search, and that's what we will be using in there. The next step, because it's a database and everything will be stored, we don't need to run the embedding and all this conversion process if it's for the same video every time. So the first thing we'll do is search if the documents already exist for the specific source video. So what we will do is extract the video ID from the URL, and we'll perform a simple similarity search, trying to retrieve one document, and see if that particular video ID matches one of the source metadata that has been stored in the database. And the source metadata is automatically filled in by the YouTube loader components in there. So next, if there's no existing documents, we just run the same thing as before. We add documents and convert them to vectors and add them to our database just with this single method in there. And that's basically it, because for the next thing, yeah, it's exactly all the same. I just needed to change the model and the database components, and everything else remains the same. So now let's run our code again and see if it's still working with the new models that we use. So we run npm start again. And this time, instead of using the local models and database, it will use Azure OpenAI and Azure AI Search. You can see that it's still loading the documents. It takes a bit longer to embed the documents because everything has to be uploaded to the cloud. And then we can get the answer for the question, what are the news about GPT-4 models? And yeah, it says it involves significant updates in partnership. First, GPT-4 Turbo with lower pricing, structured JSON, and extended prompt length. So you can see that the answer comes a bit different than with the previous models. It's also a bit more extensive. So that's something you can tune with the prompt, but that was not like the goal of the exercise in there. So yeah, basically we get the same answer with a bit more details than before. Let's run it again, because we've seen that the first time it was embedding the documents, it should skip that part. Yes, right there. The second time we run that, and then yeah, again we get a bit different answer, but with the same content overall. Like it's speaking about GPT-4 Turbo, lower pricing, JSON formatting again, extended prompt length, and so on. So yeah, the idea was to demonstrate how we went with, as you've seen, very few changes in our initial code base for our local prototype and migrate them to use Azure components. So let's just wrap up. You've seen that by using LangChain.js, it's very easy to implement like such a complex approach such as RAG using all the built-in tools and utilities in LangChain. We first built a local prototype using the phase vector database and the Ollama tool in connection with the Llama 2 7B models and the other one for the embeddings. And we transition our code with just very small changes to move to a production version for Azure using Azure AI Search with the latest OpenAI models such as GPT-4 Turbo and text embedding free large models. And yeah, of course, it wasn't like a full production application. If we wanted to put that code into an API, we would have to spin up like a server, for example, Express.js. But you've seen the most interesting stuff from that part. So yeah, just in a few minutes, I shown you that how easy it is to like experiment locally with LangChain.js and then migrate your code to be ready for production with Azure components, all thanks to LangChain.js. So thanks for this. And yeah, everything I've shown in this session is available in there. You have the slides, you have all the source code for the demo. And if you want to take it a bit further and see what a full enterprise-ready AI sample with JavaScript looks like, we also have a link for you in there. And if you're interested to learn more about RAG, we also have an in-depth workshop to learn everything you need to know about that approach. So thank you.